Welcome to Phil Talks Tech. I know it's been a while, but we're back on the air. Bit of a different one today. I've just done an upgrade to our off-grid solar system on our Caravan. So I'm going to do a bit of a rundown on what it took to do that, what I used, why I chose it, how it all worked out. I'll explain what all the components do and how they all work together. Over on the Sapphire Blue Travel channel, our other travel channel, is overview of the install. If you want to see a full list of the components, you can go over to Sapphire Blue Travel webpage. I'll put a link in the description and you can see a full list of the components there. I wouldn't recommend just everyone try installing your own off-grid solar system. I'm an elder electrician of 4 years experience. If you want to do it yourself, please seek professional advice because it can be dangerous and there's things that can go way wrong and you don't want to do that. We bought our Caravan second hand and it did have a battery and some solar panels and an inverter in there, but not adequate for our needs. So basically we went from 100 amp hours AGM battery with 320 watts of solar and a 1000 watt inverter. Not even a pure sine wave inverter, so not really up to scratch for what we wanted to do with the van. What did I replace it with? We went up to 600 amp hours of lithium batteries, 2 separate solar arrays, and I used 2 Victron MPPT smart controllers for them. So I've used the Victron MPPT 150 and Victron MPPT 130 solar charge controllers. I have a Victron smart shunt and a King's 40 amp DC to DC charger for charging from the car, a King's 3000 watt inverter. The rest of the stuff is there's battery isolators, solar breaker isolators, 20 amp smart lithium battery charge, 240 volt battery charger for charging batteries when we're on grid, and there's all sorts of other stuff in there, like fuses and circuit breakers for the 12 volt side. Victron Connect is a great app, so you can monitor everything and manage, and the software manages everything very well, so that's why I went with those. As far as the batteries goes, I don't think anyone comes close to value for money on the batteries. As far as King's goes, 300 amp hour lithiums are the best price by far out there, and their 3000 watt inverter is very well built, so haven't had any problem with running it, and I think it's a very well built component. The DC charger went for a 40 amp DC charger, and it seems to work fine. I haven't had a lot of read a lot of reviews on that one, but haven't had any bad reviews on it either. I'll try not to gloss over things and go through everything there. I'll come into more detail about each of those things as we get to them. So we all know that solar panels capture energy from the sun and convert it to electricity. And what happens from there is what we'll talk about today. I have 4 solar panels on the roof of the van connected in 2 separate arrays. So they're configured for 12 volts, and I've gone for 2 separate arrays because of shading issues when we park under shade and those sort of things, and I don't need to have a controller, a much bigger controller. I can get away with a 30 amp and a 50 amp MPPT Victron controller. So when I say arrays, I have 2 solar panels in parallel connected as 12 volts in one array, and that's my big array 1, which is on the 50 amp MPPT controller, and I have 2 smaller panels at 320 watts that are on the second array, and they're mounted in different positions on the van, and so they get sunlight at different angles and different times. So I can, as I'm monitoring, I can see that as the sun rises, I get, and depending on where we park, the orientation we park the van, one array will get more sunlight and start charging before the other. The beauty of the Victron system is all these components are networked, and so the smart shunt will switch on and off the solar arrays depending on what the needs of the battery are. So important thing in setting up all of these components is you set the smart shunt, the Victron MPT controllers to suit your batteries and your setup, and so the settings in there are important because they will limit how much charge you can put in, when it'll switch off, absorption rates, all those things that the batteries need. So that's managed in the software there. I won't go into the full detail of that here, but if you want to know more, I can do a video just on those. Some of the other bits we've used, explain for the novice. This is a bus bar, smaller than the ones I used in my build, but similar. It's just a tie point where you can have a main feed in and multiple feeds out. So the main power feed will come into this bolt here, and you can take several off. Now, for circuit protection, we use fuses and circuit breakers, and various sizes for different applications. So this is a large a mega fuse or an AGM fuse, and this is the holder for it. You see it bolts into here. This is for high current circuits like the inverter. And then you have smaller versions too, an AMI style fuse, which is these mega fuses are an AGM style fuse. These are an AMI style fuse. They're just smaller, but they're used generally for lower currents. So they're used different places throughout the system depending on what currents you're drawing. Also, main battery isolator. Big heavy lugs. Our original van came set up with an AGM battery in it, and like I said earlier, I upgraded to lithium. Now the big difference between AGM and lithium is weight and usable capacity. An AGM battery, you can use 50% of its capacity before you start to affect the life of the battery. Now lithium, you can use, some say 100%. I set my cut off at 95% just for some margin of safety, and you can run them down to that all the time and charge them back up again. It doesn't affect the battery. An AGM, if you drop it below 50%, it will affect the life of the battery. I went from 100 amp hours to 600 amp hours, which is a huge leap, especially because they're lithium and I can use most of that capacity. The weight difference. AGM are very heavy. Lithium are generally a third of the weight of a similar capacity AGM battery. So the increase in weight on our system is far outweighed by the increase in capacity. We didn't add a whole lot of weight to the van. Batteries will be the biggest part of that. The rest of the components aren't all that heavy. The inverter would be the next heaviest thing. One of the other advantages of lithium batteries is they have built-in battery management system. If it's a 12 volt style battery, it will have a BMS, a battery management system, where AGM relied on your charging and set up to control the battery. So you can't overcharge a lithium battery. If it has a BMS, it will cut off. Depending on the BMS of the batteries, they'll cut off on high temperature, low temperature, and charge rate. So your BMS will be rated for how much charging current can take, its cutout voltage, its cut in voltage, and its temperature cut in and out. Not all BMSs have low temperature cutout, but I haven't yet to see a BMS that doesn't have a high temperature cutout. In Australia, we don't get the freezing temperatures typically to warrant low temperature cutout. It's a nice thing to have. If you've got it, it will be automatic in the BMS anyway. But if you're going to alpine regions or something like that in Australia, then you want to have low voltage cutout. And some batteries even go to the point where they have to be heated when they're in Arctic tolerant conditions. We don't get them in Australia, so we're pretty safe. I fitted a 3000 watt inverter. What an inverter does, it converts your DC voltage into 240 volts or 110 volts if you're in the US. Ours is 3000 watts, it's 12 volts to 240 volts at 50 hertz. The size of the inverter you need depends on what you're going to use it for. 3000 watts is ample for us. We don't have a lot of draw. So our main things is our 12 volt appliances, a microwave, coffee machine. We have a 240 volt television. Those things, what we run off that. We have some 240 volt lighting we use occasionally. We can run the air conditioning. We don't always run the air conditioning. We've given it a trial. It works well. You're talking a lot of current, so how long you can run that for depends on how much solar you're getting. I'll take you down to the van shortly and show you how the inverter working and the monitoring of the battery with the Victron Connect app and how it works and how it worked for our trial trip. Alright, I'm just going to power the inverter on and then I'll show you on the app the draw on the inverter as we start to use some things. And we're drawing, initially we're drawing about 6 amps, but we do have some 240 volt lights on. Yeah, now we'll run the coffee machine to see what current that draws and how much it takes out of the batteries. And Karen just turned the coffee machine on, and you can see we're drawing 86 amps. So that might sound a lot of current, but it's only on for a short time. It doesn't run all day. So this is the King's in 3000 watt inverter and the remote for it. As you can see, it's drawing 1080 watts. It's a cool morning this morning, so the inverter's only 18 degrees C, so the fans aren't running on it. And our battery voltage is 13.4 volts. Like I said, it doesn't run for long, so it's actually started to taper off now.
But I'm about to actually turn it on to start.
The heater's finished its heating cycle, so we've back to 6.7 amps, so it's not drawing any current now. Karen's about to use the steam wand. I don't know if that will make it reheat again. So there we go. You can see the coffee machine only runs for a couple of minutes, so we haven't affected our batteries. We're still at 99% battery. We're drawing 80 amps for a few minutes there, so that's fine. We've got plenty of capacity, and that'll recharge in no time. So this is a bit down the track. We've actually had a trip, and I wanted to show you some of our consumption and charging and see how it's gone. So go into the smart shunt. Our deepest discharge rate was 378 amp hours out of 600, so we didn't get near to flat. And cumulative total with these 2092 amp hours. And that was a trip of nearly a week, but we did have a few days in the caravan park, so we didn't really, we were on mains then. So if I look into solar A1, this is our 50 amp MPPT. This has got 400 watts of solar on. And we'll go back and we'll look at the history in here. Currently it's not making much because it's raining and got the caravan cover over it. But if I go into the history, you can see we've been home for 2 weeks and it's just been topping up the batteries because it's been fully charged. This is the actual trip. So I think we peaked out at 481 watts on this bank. That's not bad out of 400 watts of panels to make 481. Yeah, and 1.37 kilowatt hours that day. So we've made some good solar, and we've had some rainy and overcast days. Only the one controller is turned on. It's bulk's charging. It's only making 11 watts. The battery's basically full, so it doesn't matter. So I've drawn a block diagram of the system so I can explain it a bit easier to you, so you can get a visual plan of how it works. So we have our two solar panels here. Array 1 and Array 2, there's larger panels and smaller panels. Coming through a DC breakers and switches, so you can isolate the panels if you need to do any work on them. Into our Victron MPPT charge controllers, 2 of them, and out of those into our bus bar, positive and negative bus bar. Right, so that puts our charge out of the solar panels, converts to the right voltage and current we need. Comes out into the bus bars and then through the batteries, through the main battery isolator, so we can turn all the power off from the isolator if we need to just quickly shut everything down, or if we want to do any major work on it so we have no live power. And then the negative side goes to this bus bar, but before it goes to the battery it goes through the smart shunt, so that measures and reads all the power being consumed or made, so it will give us the draw but also our charge. So that's what the smart shunt does, and that's all linked with these two by the Victron Connect app on the Victron's network, and so we monitor all that's going on through there. Okay, over here we have our 3000 watt inverter. We have a main fuse on that. If anything goes wrong there, it'll pop that fuse. We have, and they both connect to the bus bars, and then on this side we have the DC to DC charger, which connects to the car, to the Anderson plug on the back of the vehicle, and it gives us up to 40 amps charging back into the system when we're driving. And this last piece here is our battery charger that's connected to 240 volt mains, only connected to shore power, not connected to the inverter, because that would be pointless, because the losses in it, you'll go backwards. over here have a 50 amp circuit breaker which feeds to our Caravan electric 12 volt electrics, mainly the fuse boxes in the Caravan. Just a note on hooking up batteries: when you're putting lithium batteries in parallel, you join the negatives to negatives and positive to positive, but one thing you need to do is have equal length cables on both your positive and negative, and also you need to come off the negative on one bank of battery and positive off the other, so that equals your length of cable up again. So that's an important one, because it does get a bit out of balance otherwise. Like I said, the Victron Connect app monitors all that's going on, and it automatically switches the arrays on and off depending on what the demands for the batteries are. So if our batteries are low, we'll get maximum solar in, but when they're getting charged up, it'll switch whichever solar array off that it determines is all the power it needs. DC to DC charger in the car starts putting 40 amps in. The smart shunt will turn the solar off as well, so it only gives the batteries what they need. So it is a good system. That's why I chose the Victron smart shunt and charge controllers. If you need to ask me any questions, you can leave a comment below the video. If you want to see the full install, jump on over to Sapphire Blue Travel. That's where we did the install, so you'll be able to see it all there. If you like what you saw today, why don't you subscribe? Thanks for joining us. This is Phil from Phil's Talks Tech.